I'll now be creating a basic setup for buildings. There are numerous approaches for buildings, and the approach which you choose will vary depending on your needs. I'm initially starting with buildings which have very strict parameters, which will allow me to construct gameplay around them. The majority of buildings which we create in games will actually be far larger than buildings which are used in real life, and they tend to be a large amount of buildings with huge hallways and very large open rooms. I want to create a system which can allow me to cover those kind of spaces, as well as some more basic smaller buildings. Initially, this asset will be for building layout. It won't be focused on major details for the building, as I'm still trying to decide on functionality, and the functionality of the building should drive the way we approach the building. I'll start by getting a geometry node. I want to be able to create these buildings using basic geometry. I don't necessarily want to have to create everything within Houdini. I will be using Houdini Engine for this, so I want to be able to use basic geometry which can be created within the game engine. One of the most common basic forms of geometry which I want to be able to use will be a cube. So I'll be using rough geometry, and our building will be constructed based off that. I will of course need some scale, and my basic point of reference for scale is Tommy. So I'll get a copy of the Tommy test geometry. This will give me my basic setup. I can now enter my geometry node and we can begin working on the building. So essentially I can get a box. I can then manipulate this box. I will want to be able to take a box like this and convert it into our building, but I do not want this to just be a single box. I want to be able to use multiple boxes and use multiple items like this to create our layout. So for example, I could duplicate this box. I could then merge it with the previous box. This could then be scaled as well. I then use a number of boxes like this to construct our building. This will allow us to do things like create overhangs and quickly construct any basic form that we want. So we'll use this to quickly block out our buildings. So this will give me the basic approach to laying out the building, and this geometry will now become my test building. So I can rename this node to test geometry. I can then start working on the main HDA, so I'll need another geometry node. I'll call this node building. I'll then convert this node into an HDA. In the parameter interface, I'll hide all the default parameters, and I can now start to work on this building. Initially, this is going to be a very simple setup. We'll be converting our boxes into a single piece of geometry, so I'm going to import my geometry into this node, and then I'm going to convert it into a single piece of geometry, and in this case that geometry will be a signed distance field. We could also use a volume, but the volume is slightly more difficult to work with in terms of geometry. We may use volumes at a later stage, but initially the signed distance field will be more straightforward. I'm going to be generating the signed distance field using a VDB, and I'll be doing this with a VDB from Polygon node. I have not yet got my geometry, so I'll need an object merge node to do this. This object merge node will be connected to the first input of my VDB. For the object merge, I'll initially refer this to my test geometry. I'll do this with dot backslash, and then I'll reference my test geometry node. So this will give us our geometry, and it will give us our geometry as a signed distance field. We could also convert this to a volume, and then we could scatter points throughout this volume, but in this case I do not really need to do this. We'll unify our geometry by converting this into a VDB. We'll then convert this straight back into geometry. This will give us very dense geometry, although more importantly it will give us a unified piece of geometry. This geometry is very dense, and none of it is particularly useful, so we're going to convert this into geometry which is far easier to deal with, which will be far more sparse. We also want this geometry to be consistent, as we want to be able to replace parts of this geometry easily. So essentially I want to convert this into a number of basic rectangles, and these rectangles are all going to be higher than they are wide. I'll give all of these a width of 1 meter, which will just give me a uniform value to deal with. For the height, I'll initially set this to be 3 meters. 3 meters is slightly higher than your average room height, but it will give us a consistent value, which will be easy to deal with. And differences in centimeters do not really matter in this case, as no one will really pick up on it in a game, and they're usually slight variations in any case. The height is also a property that we will want to be able to control eventually, so starting with a uniform value is usually the best idea. After I've converted my signed distance field to polygons, I'll get an attribute wrangle node so we can manipulate the point data. Here I'll be modifying the point position, and I'll start by modifying the point position in X width at P p.x. I'm going to start by rounding this down, and I'm going to round it down to an integer value. To do this, I'll use a rint function, and I'm going to round down the x value for the point position. So this will be at p.x. I'll need to do this for all axes, so I'll duplicate this line. We'll then round down the y position with at p.y and the z position with at p.z. This will give us a more box-like structure. We'll have a far more simple geometry, and all of our joints will be placed along a grid. This is closer to what I want, but the height is actually not correct. I want the height to be 3, so I'm going to divide the integer value by 3. This will give us a shrunken version of the geometry, and having divided these by 3, we'll see that we actually have a lot less geometry, and that we've lost divisions on our vertical scale. This is actually the result which I want, as currently we have 3 vertical rectangles, and I do not actually want multiple rectangles. I only want one rectangle per floor. Essentially, we now have a normalized building, which will give us the exact base geometry we want, even if the geometry is not scaled correctly. Since the value is now normalized, I can actually multiply the result by a value, and since I want the height to be 3, this value will be 3. However, we could set this value dynamically, and I can set it with a float. Before we calculate this, I'll create a variable. This will be a float, and I'll call it y offset. I'll set this with the channel function, and this will be a float value, so this will be CHF. I'll give this slider the name offset. I'll then create the slider. I can then replace the 3 in the equation with the offset value in my slider. I should now be able to dynamically adjust the height for each floor in the building. And this appears to be working, but this actually gives issues, as the point number values will not always work correctly. So there are other options which we could use instead of rint, and these options are floor and ceiling. Using the floor function, all the points will round down to the lowest possible value. This means that we do not have the risk of truncation, which is a possibility with the rint function, as it will always be using the lowest possible value. The other option is to use the ceiling, and this will round all our values to the highest possible value. So if we have 0.1, this will become 1, and 0.6 would also be rounded to 1. With the rint function, this will be different for each point, and with the floor function, this will always round down to the lowest value. I will use either floor or ceiling, as the general rounding of integers means that we may have issues where the points do not always line up perfectly. This can lead to issues with point numbering. It can also lead to points snapping into the wrong place. This will lead us to having geometry which will connect diagonally. This is not an issue which I'm currently seeing here, but it is an issue which can happen, and this is not a problem which you'll encounter with the floor or ceiling functions. I will attempt to show the possible errors, but I do not know if this will work. I'm not seeing any bad examples, but if we look at this particular value here, we'll see that one of our points is collapsing. I can now get an output node, and this will give us our building. I'll change my function back to the ceiling function. Next, I'll edit the parameter interface for my attribute wrangle node. I'm going to move my slider to the top of this node. I'm also going to change the range of the slider. It will start at 1, and I'm actually going to lock this at 1, as I'll never need to have it below that value. I'll then set the maximum value to be 10. I'll add a default value. I'll do this by editing my channels, and I'll set the channel value to be 3. I can then edit the type properties for my HDA. I'll add my Y offset to the parameters, and that will give me my basic interface for the moment. However, this will not work, and that is because of my object merge node. Currently, I have external references. I should not be referencing my mesh directly through the object merge node, so I'll delete my path value, and I'll add the object path to the interface. I'll then change the parameter name to be geometry. The label will also be geometry. I can apply to save my changes, and I can accept. I should now be able to use the HDA interface, and here I'll select the test geometry again, and we should once again have our updated building. I can then save my node type, and I can match the current definition. I'll then export this to Unity. So now I'm in Unity to test how this is going to work. I'll start by going to my test scene folder, and I'm going to duplicate the test scene for my character. I'll then create a new folder which I'll call HDA test, and I'll place the duplicated scene within this folder. I can rename the scene to test building. In my HDA folder, I should have a buildings folder, and here I should now have an HDA for my exported building. I can drag and drop this onto the scene, and we should have nothing visible. I'm going to be creating my building with cubes, so I'll create a couple of them. I'll reset both of these so that they are in the center of the scene. I can then scale these and position them. This is nothing particularly interesting, but it will allow us to test, and it will give us our initial building. So I've created my basic geometry, and I can now take a look at the building HDA. I have my offset, and after that I have my geometry. I'll set this to use a Unity mesh. I'll add 2 slots as I've added 2 boxes. I can then assign my boxes to these slots. I'll do this by dragging them from the hierarchy onto the slots in the inspector. I can then hide this geometry, as we do not actually need to see these boxes. I will also need to reset the position of my HDA, and now I should be generating the building dynamically. I should be able to adjust the height as needed, and this should give me my initial building. I should also be able to test now, and I can move my player around in relation to the building. This doesn't mean very much yet, but we will now be able to work on interactions with the building. That will give us the initial building. There is, however, one major thing which I have forgotten to do here, and it severely affects the performance of this HDA. That occurs just before our output. If we look at the individual points, we'll see that we have very large numbers for these points. Here I have moved the points, but I haven't consolidated the points, so we're still working with all of the points which we had when we converted our geometry initially. We want to get rid of all these extra point numbers, and to do this I'll get a fuse node. The fuse node can be connected to the end of the network. This will get rid of all the extra points. It'll make our geometry cleaner, and it'll make our geometry easier to work with. I can then save the node type, and I'll export the geometry again. So this will give us the basis for the building. We can now create building systems from this, and there's a lot of work which we'll need to do here. So we'll need to work on the building itself as well as the interaction for the building, but this will at least give us a start.